I'm really feel that both of you carry, a great amount of experience, exposure, expertise to guide our audience, viewers who will be watching this, both, in the form of the live transmission, which is happening on our social media platforms, as well as through this webinar. One of the key stakeholders that we address through these webinars and who are the main focus is the students and aspiring architect students specifically. So a lot of questions that will be asked today come from them, and of course from the current architecture students also. So I really hope that you find these questions as interesting as we did when we were looking at them and framing them. So on that note, once again, warmly welcoming both of you and starting our webinar. Neha, over to you.
Thank you, Mitla. Very good morning, everyone. GHRDC welcomes you to today's webinar titled The Future of Architecture Education in India, Innovation in Curriculum Design, Sustainability, Climate Change, and Inclusivity. Thank you, everyone, for taking out time and joining in with us today. We're very delighted to have with us experts from industry and academia for this discussion today. On behalf of GHRDC team, I would welcome our expert panel members. So GHRDC, as many of you would be aware, is a 27 years old education research firm dedicatedly working in the education sector in the area of ranking, training, mentoring, and research with the very sole aim of working on upgrading the quality of education in various sectors and benchmarking the best of educational institutions in our country. Talking about the future of architecture, education, and industry, it's changing and it's changing very fast, driven by technological advancements, increased focus on sustainability and climate change, incorporation of social and ethical issues, and many more such dynamic changes. Today's topic is about the discussion of such changes and their far-reaching impact on architecture education and mindset of architects of today. We will now be inviting our distinguished speakers to talk about this very exciting topic. Also, I would request our wonderful attendees as well as our viewers on our live session of this webinar to type in any questions you have for the speakers in the chat box, which is given along with the name of the speaker you want to address your question to. Now, I would like to request our Deputy Director and Ranking Head, Ms. Aradhna Chankagoti, to introduce our eminent speakers for today. Over to you, Aradhna ma'am.
Thank you, Neha. Good morning, everyone. I'll now introduce our distinguished speakers for today's webinar. Professor Srinivas is a distinguished academician, teacher, researcher, and an institution builder. A PhD in architecture from JNTU Hyderabad has to his credit of being an author to 9 publications and key contributor to the preparation of resource materials for the compiled reader volume of Bachelor in Architecture book, History of Indian Architecture. Professor Srinivas has had a rich experience and has given his invaluable contribution to prestigious projects such as delineation of metropolitan region of Hyderabad, parking facilities plan for Hyderabad Urban Development Authority for 400 four-wheelers and 1,000 two-wheelers in the city central area, being a key resource person for key computer application in planning, a course for Huda officials organized by the School of Planning and Architecture, Hyderabad, urban planner project team for the eco-city development plan for the core area of Tirupati town, to just name a few. He has also regularly taught in various architectural studios on a wide variety of topics and conducted architectural design studios on kindergarten schools, hospitals, museums, institutions, and housings. We warmly welcome you, sir. Ms. Shipra Datta, a graduate in architecture from BIT Mesra. Ms. Datta is a dynamic, creative, and passionate business leader with about 23 years of experience in public sector advisory, infrastructure consulting, management and operation, business development, and independent handling of businesses with multi-sectoral exposure. In the past, she has worked with big brands like Fitzner, Aziz, and Roddick, and currently works with a renowned quasi-government organization called IDEC, which is a joint venture between the government of Karnataka, IDFC Foundation, and HDFC Bank. In this role, she is responsible for the entire gamut of business development for India and international market for all the infra and building sectors. Shipra has been instrumental in the company's growth model, strategies, geographical and sectoral expansions. She has worked and still working on many signature projects of India, including smart cities, master plan, tourism and urban development, water infra and transportation projects, etc., and takes immense pride in being a major stakeholder in the nation building. At one point, she managed projects worth 75,000 crore INR and handled more than 130 engineers, planners, architects, and other experts. She strongly promotes the power of networking and thrives on her extensive and supportive community. She has also been invited and recognized as a panelist and guest speaker at various public forums and prestigious technical and management institutions, IIM Ranchi being one of them. She was a keynote speaker in the prestigious G20 World Water Summit, where she stressed upon the importance of a sponge city, which according to her is a very basic concept of sustainable living. In her personal time, she takes up workshops on dance meditation therapy and works closely with NGOs, corporates, and kids. She has also been a prime member of Delhi Drum Circle, which is a worldwide concept of community music jam session. We warmly welcome you, ma'am. And we have Ms. Mekhla Sinha, the Executive Director of GHRDC, who will be acting as a moderator for the discussion today. With this, I would request Mekhla to now take over and initiate the panel discussion.
Thank you so much, Aradhana. Thank you, Shipra. Thank you, sir, for joining us today. Like we said, this is a very exciting topic that we wanted to take up today based on the kind of changes that are happening in the architecture, education, and industry model. So we'll be straight away jumping on to the questions. And my first question, sir, will be to you. We have been seeing a lot of changes that are happening in the architecture education space specifically, obviously, which has been influenced by the changes that are happening in the industry, whether it is increased integration of technology, whether it is sustainability, a lot of focus on climate change, inclusivity, and of course, human-centered designs, designs which are absolutely matched to fit the needs of human comfort, not just in terms of physical comfort, but also for issues like mental health. So keeping those kind of changes in mind, how do you see the curriculum of architecture education being reimagined in today's time, which can prepare our students of architecture in a much better way? Over to you, sir.
Yeah. Good morning. I just want to do a small correction to my introduction, which was given. I could not complete my doctorate. Probably I've left it in between. Yeah. So it's a very interesting question, and it's a very, very long question. And it is something which is, I think, touching the basics of the fundamental issues relating to architectural education. So if we go back to basics, I think architecture is shifting the paradigm from art to technology very fast. And that we see in the last few decades being very, very quick. So once upon a time, architectural education was more relating to individual taste, individual, interests. And so it's more based on individual kind of efforts. Now it's a teamwork, and it is not for an individual or for individual interest, but it is for a larger interest. So then it is also moving from, very, very subjective discussions earlier to a very, very objective and clear kind of, things which are emerging, which is functionalism, which is very, very important these days for architecture. Similarly, the third thing that I would like to say is earlier, they're very, very specific. Like suppose if I build a house, it is for me and it is for my liking and it's more of relating to personal or small group interests. But now architecture is going to a very wide interest. Even if I have to build a house, it has to probably satisfy a lot of things for more user group than individual taste. So from a very simple earlier focused on to a small group or individual focus to now it is getting to we are designing buildings which are actually you don't know the end user at all, and end user keeps on changing. Many such kind of buildings have been coming. So there are a lot of understanding of psychology, thinking process. In fact, to if we look at today, AI is emerging as one of the very fast getting into every field. The most important aspect of handling AI in architecture would be critical thinking. The students should be in a position to make out what is real, what is unreal, what is correct, what is not correct, what is appropriate in a particular situation. They should be equipped very well with, otherwise they will be withered away by some very false information, and then which can actually affect the architecture manifestation in a very big way. So then the whole thing that, as you are initially talking about, the sustainability becoming a very important part, and for a large part of it, sustainability is just a lip service which is being going on. But in reality, if it has to really take up, it has to go back to basics. In fact, it has to go back the way William Curtis was talking about in his authentic regionalism. Go back to the traditional architecture, and there just not copying traditional architecture but getting into the depth of it and try to understand and implement in today's technology and material and situation, which actually requires an in-depth study, research, and every project, every design exercise, every project that is taken in academics should be a deep research. So architects should now get into a proper deep research mode with an appropriate, scientific methods, rather than very objectively. They have to get into research and find out the truth, and then that knowledge which emerges will actually be very fruitful in trying to be very sustainable. The earlier wisdom, the traditional wisdom, and today's technology has to be combined and matched, which by no means is a very small thing, which is a very difficult thing, and that is the need of the hour to address either the climate change or the sustainable goals that we have or requirements that we have. So in order to do all these, I think there should be a architecture students have to be taught thinking as a very important part. In my opinion, I strongly feel that architecture is about 95% thinking and rest of it is just 5%, which everybody gets carried away by this 5%, which is just the physical manifestation in terms of drawings, maps, or whatever. But the 95% which is going in the background as a thinking, which has to be the students have to be trained in this particular thing, where we have very systematic ways of looking at critical thinking, creative thinking, conceptual thinking, problem solving, and all these various kinds of things have to come in, and which should be taught as a skill to the students. In fact, in our curriculum, we started this very first semester. We are teaching them these thinking skills, and at least the students would appreciate for various kinds of purposes. You have to use a different ways of use of mind in different ways, and which is a very important part of the today's education. Then it goes to sort of research methods. Also has to be, we need not have to talk about no PhD research, philosophical level research, but if we are talking about case study, it's a research method. It has to be taught as a research method rather than just in some studios, students are just getting some pictures because nowadays it's all possible. They get pictures and then put them as an album there, and then at the most they might write some few comments here and there. And that is becoming a case study. So we have to go in depth and try to understand, and that depth is I would focus more on the method. Actually, it is there in the curriculum. Case studies is a very, very important part of the studio. But the method in which the studio has to, or rather the case study has to be conducted, has to be there as a part of the curriculum. It's not that you just leave to the students or to the studio in charge, but there should be, these methods have to be laid down in a systematic way, and people have to do research on it, write books and publish and guide the young minds in all these aspects, which so research will get into, because if we are talking about again William Curtis concept, if we have to get back to that level, requires lots of research, very scientific observations, and then through which you have to evolve to the conclusions and come up with, it is talking about a very high level involvement when compared to, I mean, which is my experience is where architecture, generally we tend to be very, very superficial in terms of, we will be rather jack of all and master of none in many, many, many ways. So, which we have to probably change a little bit, get into the depth of issues and share this knowledge, and different specialized people have to get into this. Suppose if I encourage rather group work in design, where there are 4 members in design, somebody gets into depth of something, somebody gets into, all of them as a team together work and then produce. This kind of team building is quite essential even today in practice, if we are talking about sustaining into future architectural endeavors. So I think all in all, we have to have a major change in the methodologies, and we have to transform the curriculum, getting into more technological issues, and then leave some of the subjective matters, which we give a lot of emphasis to, very, very objective and very scientific and rational based education has to get into the future.
Very aptly answered, sir. I think you covered and touched upon some of the most crucial aspects that institutions, especially in the area of architecture and in general also, I think should take away from this sort of a response. You talked about the role of AI, understanding the psyche and the psychology of the end user, which I think is a very important aspect, interdisciplinary way of thinking. And then you also spoke about the process. I think the fact that you were emphasizing so much on research and innovation as part of the process itself of becoming an architect, I think that is something very big for institutions to take back from. Thank you so much. Ms. Datta, my next question is to you. I will reframe this question. It's almost what we asked, sir, but I'll just reframe it to you a little bit differently. So in terms of the gaps that we spoke about, I asked sir about the kind of changes that are required in terms of the curriculum in today's time. You being a part of the industry for more than 2 decades have seen numerous changes happening in the architecture sector. What kind of changes would you suggest to architecture institutions to do, or what kind of steps would you suggest for them to do to bridge some of these gaps that today also exist between the industry and the institutions, specifically in the area of architecture education? Over to you.
Thank you, Meghla, for the brilliant question. Sir has already answered a lot of gaps. And I can see that a lot of changes are already happening in terms of these gap fillings and the way we have reoriented ourselves. But I have all these young architects and planners who join me for different projects and every day. So that's where I come from. So my 2 cents, my perspective on these gaps and the solutions. So I'll take it point-wise, okay? First point is integration of technology and digital tools. So many architecture schools, they still focus heavily on traditional methods of design and construction. So while these skills are definitely essential for developing these conceptual thinking and spatial awareness, the industry increasingly relies on advanced technologies like BIM, computational design, parametric modeling. So I think these schools should incorporate digital tools like these, Revit, Rhino, Grasshopper, into their curriculum from the very beginning. This can include offering workshops, then integrated studio courses, and even dedicated courses on emerging technologies like AI, 3D printing, VR, AR. Industry schools can actually collaborate with technology companies and industry professionals to ensure the tools taught align with what is used in practice. So one is that. Second is emphasis on sustainability and environmental awareness. Sir also broadly touched upon this particular aspect. So while sustainability is often a component of architecture education, it's not always kind of deeply integrated into every aspect of design and planning. We talk about it, but then we forget about it. So as climate change and resource depletion are becoming really, really urgent, the demand for architects who can design energy efficient, carbon neutral, and adaptable building is growing. So schools should embed sustainability principles across all aspects of the curriculum, not just as an elective or a single studio project. This means considering the environmental impact of materials, energy systems, and building performance from the start of the design process. So how do we do this? So collaboration with environmental engineers, urban planners, sustainability experts, social experts can ensure that students are exposed to a holistic approach to sustainable design. Architecture schools could also partner with, again, industry leaders on research projects, like Sir said, which is focused more on developing innovative green building solutions, right? Third point is collaboration with other disciplines. So you see, when I was studying architecture, things have changed a lot, but I still feel somewhere this architecture education is often siloed with a strong focus on design, aesthetics, and technical construction, of course. But the modern architectural practice requires collaboration with different stakeholders. It could be specialists, engineers, planners, sociologists, policymakers, especially in large-scale projects or those involving social impact. So to address this, the schools should foster interdisciplinary collaboration. This can again be done through joint studios, cross-disciplinary projects, or collaborative workshops that bring together students from architecture, engineering, planning, environmental science, etc., etc. Okay, so encouraging teamwork and teaching students how to navigate and negotiate with these different stakeholders will help them understand the complexities of real world projects and develop skills in communication, project management, and teamwork. So that is third point. Fourth point is a practical experience and what I say real world projects, which we are doing. So the gap is while students receive extensive theoretical and design-based training, and they are like brilliant at this. Some of them are just mind-blowing, but they often lack the hands-on experience that would allow them to understand the realities of construction process. Budgeting, most important, and the regulatory landscape, which some of them are aware and most of them are not aware of. So industry projects are often disconnected from academic learning. So one way to bridge this gap is through internship, of course, live projects, collaborations, not just with architectural firms and studios, but also municipalities or non-profits. Some of these NGOs are doing brilliant work. So maybe students could collaborate with them, establish a strong relationship with industry partners, and offer students opportunities to work on real world projects, either as part of their studio work or through these internships. Additionally, what I think these schools could host design competition that simulate real world challenges, forcing students to work under pressure. Not that they are not already under pressure, but then this would kind of really force them under pressure to work within constraints, which is time, budget, client demands, so which they are right now not aware of. Then my fifth point is focus on social and cultural context. So while they are brilliant at what they're doing, I think sometimes these schools, they focus too much on the formal aspect of design, neglecting all the social, cultural, and political context in which architecture operates. However, the industry increasingly demands architects who can design spaces that are not only functional and aesthetically pleasing, but also responsive to the needs and experience of diverse communities. So, solution is school should include a strong emphasis on social responsibility and ethics in the curriculum itself. This includes teaching students about the cultural, economic, political implications of their design choices and how to create spaces that are inclusive and equitable. Introducing subjects such as participatory design, community engagement, and social impact could help students become more sensitive to the broader context of their work. Right? Sixth point is one of the most important point, which we somehow miss during our education. And this is, I recommend this very strongly, which is entrepreneurial and business skills. So these architecture education tends to focus heavily on design and technical knowledge, with very limited attention to the business side of profession, such as project management, contracts, entrepreneurship, budgeting, finance management. We just do not talk about this. So as many architects work in small practices or they start their own firms, understanding financial management, marketing, and business development is very, very crucial. So again, I suggest that schools should integrate courses that teach financial literacy, entrepreneurship, PMC, contract law, contract management. Additionally, fostering skills in communication, leadership, and negotiation would prepare students for the challenges of running a practice or navigating large-scale project management, which we are doing right now. And I faced a lot of challenges when it came to business side of work. So it's one of the most crucial thing I would suggest for the schools to incorporate. Then comes global perspective and organization, which is my 7th point. So these architectural profession today increasingly deals with global challenges such as urbanization, migration, which is the key these days, and the integration of diverse cultural needs. So education often takes a more local or let's say regional focus, with students missing out on broader global perspectives on design challenges. So the solution is incorporating case studies from various global contexts, as well as opportunities for international collaboration and study abroad would definitely expose students to the diverse challenges architects face worldwide. Schools could offer design studios focused on megacities, informal settlements, or global climate change issues. Engaging with international experts and stakeholders would also broaden students' perspectives on the built environment, is what I have to say. So I would conclude by saying that to bridge the gap between architecture education and industry needs, schools must evolve their curriculum to incorporate a more integrated, practical, and interdisciplinary approach. This means embracing technology, sustainability, real-world collaborations, then taking up social responsibility and business acumen. So that's my 2 cents on your question. Thank you.
Thank you so much, Shipra. I think what you're talking about is a very holistic, essence of what we're looking at in terms of the architects of today, where we're talking about their design-oriented thinking or their aspect related to the course or whatever internship they've done. But we are asking them to go many more miles ahead in terms of understanding much more, in depth of certain areas, like you mentioned, budgetary aspects, regulatory aspirations, having an entrepreneurial mindset and way of thinking, and really looking at it from that perspective. I think that is something which is a lot of insightful inputs for institutions to take from. Thank you. Thank you so much. Sir, over to you again. We spoke very little in the beginning about two very important areas, and you mentioned about it in your first question. I wanted to take it a little bit more in depth with you. The first is about the concept of sustainability, and the second being climate change. These two areas are now becoming increasingly in focus, specifically in the area of architecture education. How do you think architecture schools should promote sustainability and climate change in the way they are delivering education and preparing their students?
Yeah. So first level architecture should teach the students the value of sustainability, which is a general education, which every individual education, global education, they require this. The concept of think globally and act locally, which so there are certain sustainable aspects are very rooted to certain environments, and they are sometimes very specific to certain aspects. So with the time, what happened is we have done so much of advancements in terms of our technology and science and all. We have gone far away from the nature. This is what is the basic thing that has happened. In the process, our interventions in our general way of life itself into the nature is threatening the nature now. That's why we are now concerned about sustainability, because to hand over this land as we have got to our next generations is what is simply defined as sustainability. And we have to hand over without making many harmful changes to present develop. Not only that, we have to develop it, refurbish it to close to nature, and then get it back to the people. So in this whole process, I think this requires uh, on one study is trying to get back to the old wisdom, because previous people, when traditionally they were very their practices were very sustainable. There is no need to talk about if we are talking about architecture which was done earlier was totally sustainable in many ways, and where they have learned to sort of do with permanent materials for some eternal buildings, and then for residential and other buildings with very ephemeral and very rather environment friendly materials. To just give as an example, now a farmer who is growing rice would just use the straw rice, this one, as a roof for his covering material, and then which he gets every year. Those days, once in a year, they had a crop, so they get it, and then they replenish their roof again, go back, and so basically and it is actually totally 100% environmentally degradable material, and very few bricks were used in their houses. It is just the mud which is put together, and then it just merges into the environment very fast. So from that very simple lifestyle, now today if we look at every little thing that we are touching is not degradable and causes harm to the environment and things. So in the widespread understanding of this, I think there should be a lot of advancements relating to the materials, and materials have to become very sustainable, because large part of it that we are using in architecture is materials which have to be sustainable in many ways, reusable, without much harming. They should be recyclable, or they should be by nature sustainable. So that material tagging and understanding, so there's a lot of research which has to go into, because architects usually do not get deep into the materials and manufacture, and that process is very less. We only use materials, but we don't get into understanding the materials so much. So, and today the basic material that is being used in interiors, the plywood, which itself is not a very sustainable or healthy for us. So, and there are not many alternatives which are available so easily. So, healthy materials, probably good materials, require a lot of research. That research also has to emerge from architectural discipline, because it's a holistic. When it emerges from architectural discipline, it will be holistic, in trying to understand the needs and then getting into. So the perfect replacement for plywood itself is not available in totality, in terms of which can be used by common man. Which is very specific materials are. So this is how I think people have to look at and do some kind of research. Is one very on material itself is one. How to use the material also, and how to also get into the sense of, see, this sustainability can be also taught as a value of don't be greedy in terms of, or how that comes down to how you economize on the space utilization also. So that we get to see that there are trends which people want to make very grand, very huge, very big. In Hyderabad, we get to see that people want to have 5-bedroom houses and 8-bedroom houses and things like that. The apartments are being built one full floor as a 5-bedroom apartment, and you have that hundreds of stories which are coming up. So these are all, see, ultimately, in a small, all the families are becoming very small, and then I don't know why they need and what is this coming up as a value system, which again, the architects have to take a big role in it and try to see that the space which is not extra unnecessarily built, which is going to be a big non-sustainable practice. Because we get to see, we understand that, okay, Singapore and other places where they are very economical in terms of usage of space, especially Mumbai in India. And but there are different kinds of trends which are emerging in different states and in different ecosystems, which I think should also be taken up as an architectural education, and how big is big space and how to be economizing on resources. Because in future, natural resources, whether it is land, water, or anything. So if we use up now, what kind of sustainable that we are coming up with, we have to basically not use up all the land that is available. Because it's available, we can't get into it and try to spoil the agricultural land, and in future probably we may get scarce about material, I mean food also. Kind of the urbanization is so fast, and it is getting into the very fertile lands are being used now for urbanization, which might spoil the future. So which might be a big threat to the sustainability. So when I'm talking about this basic root thought process has to be there, whether the student eventually gets into architecture, urban planning, or urban design, or any further into built environment, should have this value system. So sustainability as a value system has to be taught with case studies, with examples, with the past examples, with which is a very important thing, rather than, I mean, of course, real techniques and all have to be taught is a different thing. Without value, these techniques will not have a meaning. So deep-rooted understanding of sustainability is a very important part of today's education. Further, whatever today we are teaching certain kinds of sustainable practices, which eventually will change within 5 years, 10 years down the line. So there are lots of advancements that are coming in this area, which are very fast. Some of them are emerging. So the core values are very important. So the core values of sustainability has to be taught maybe 1 or 2 semesters in the beginning course, where they have to be touching upon probably the past wisdom, then into future how they have to use those things, and then get to understand. The student has to appreciate the core value of sustainability, which he can advocate while he's getting into practice, either it is as an architect, or urban planner, or urban designer, or any level of this one. So that is the first very important part of it. And this core value education system, which people might argue should be there for every individual who is getting educated, even in degree, That's why I think UGC has introduced a module which they are calling environmental science, which has to be there in every degree as part of it. But that is just a bit, just a beginning for architecture, which has to be taken forward. And we have to look at sustainability, climate change, and all these aspects at the root level, trying to understand the core values of it are very, very important so that they can carry out throughout their life, which is the first level. The second and very, very important part of it is understanding of the climate. We all have in all our curriculums, we have climatology, but one very, very important aspect of the climatology, the way it is written as a syllabus or the way it is taught in many, many places is that, again, climatology is just as a subject and which is a standalone kind of a subject which the students would study and then probably write the exam and forget probably. Where the applications of it has to come into, which should be taught as a applied science, or which has to get into the studios, which has to get into the integrated into the entire process and decision making, which has to be taught as an important part of the curriculum. Which the basic problem for this, as I see, is not all the architecture teachers are climate experts. So there are every school will have 2 or 3 maximum experts on climatology. They teach standalone subject with a lot of enthusiasm and vigor, and it gets to the student. But again, it's not carried through the studios, and when even if it is carried through the students, the tacit knowledge of climatology is not really there with the students or with the teachers as a, so that they can critically review and view and try to understand the whole thing. So which partly can be taken over, or rather solved by using these all the software that we have, all evaluation software, visualization software that we have, simulations where people can, the students should quickly simulate. To start with the simple first year studio, you can have some kind of a built environment, and they can model it in SketchUp and start looking their shadow throw patterns just in SketchUp without any other additions or anything. Just do that and try to understand how the shadow is happening all through the 12 hours of the day, and how it is changing along with the season, and have a tacit understanding of that. Do some observation studies of such shadow patterns, which is outside with some buildings, experience them, take pictures, which actually Tado Ando's one of the publications I saw, which he would sort of it's a set of gallery of pictures as to what happens almost 12 hours within a day, how light is changing in that space. Is a study which is done and put there. So why not every student do such kind of work and study and understand, and how it is making the change, and how and also get back to local or regional studies as to how people have used the shades and shadow patterns in their architecture or built form, or it can go up to where we study that people have had shaded pathways, and these shaded pathways have come basically because the buildings were put according to the height, according to such a scale where they just mutually shade the pathways on which they walk in very hot climates. So why not we get into those case studies and try to teach those things, and ask the students to simulate that kind of built environment and understand these values and get into. So this is for another study. It cannot be only studio there, but it should be a separate study of innovations, or rather learning from the past or whatever, simple for the sake of doing scientific studies, simulations of built environment, and generalizing certain things and learning from there should be there as a standalone subject, which will again get into because a lot of it has to be achieved through design. Now the sustainable practices are, most of it is our add-ons. So we say, okay, you use less water by putting this fixture, do this. These are all more of cosmetic treatments to the existing same similar buildings rather than the basic level understanding. So the value system, one of the research or PG student found that there was she was to design an office which is having a western facade, and in the western facade, obviously for the showrooms and all that, she has to use a lot of glass. End up using the glass, and then she did simulation. This I'm talking about almost 20 years back. This study was done, and the student found, suddenly she realized that in summer about 150% increase in the load of the for energy for cooling that space just for few hours in that summer. So now because of the software that is available, different kinds of things that it tracks down back to the hourly kind of study. When it comes to the hourly study, then what you can you just have to block your building somehow during those hours. Rest of it, you can keep your showrooms, etc., open. Absolutely, it doesn't make much of a difference, but only few hours, which is very critical. So if you can take 10% of those hours during the summers, or sometimes it could be 20%, whatever, but those crucial things, if you can analyze, today it is possible to track those things, and then use some kind of a mechanized process for this. Another study which is very, very interesting is they are talking about virtual sensors. So where you try to sort of simulate the buildings, think that there are certain environments which are there, which is in the climate, and try to sort of, instead of, because you can't afford to have sensors, even if you can afford to have so many sensors, you will not be able to maintain them, which itself is a big little dust collection that the sensors won't work. So when you go back to these virtual sensors, you are able to sort of simulate the building for about a year, 2 years, 3 years, and set up certain behavior for the building in terms of closing the windows, closing the shutters, closing the glass itself through certain devices and things, shade them, and do all those processes. And then you can again connect this to your own monitoring system and study, and the machine starts learning and behaving as in which times it had to sort of overrule the existing patterns of the behavior of the buildings that is studied and simulated. And then that little difference can be corrected, and within a 10 years process, if you can really simulate and use this artificial intelligence and machine learning into place, it can actually adapt to any kind of environment for which it is designed. So these are kinds of things which have to be, if you want the students of BARC level, do these kinds of experimentations, which requires a lot of technical skills and multidisciplinary approach. And rather than a fixed curriculum, I think the curriculum should be based on the expertise that is available, and based on how you can pull in different kinds of experts and put. So the curriculum, as maybe about 75% or 60% can be fixed, through which going 40% should be little more experimental, should allow these kinds of experiments which can be done, and through which years of learning can come. So if say 10 years, if you are doing this process, now all your 10 years students will learn all these things, and which is going to be, and then that can be leading to a great understanding of which can get into architectural realm, and then publish publications, and people read and becomes very scientific. And because the way I understand and see is, very less of this information is research is coming out from architects. Sometimes I see mechanical engineering getting into these kind of studies. Most of the time, electrical engineers getting into these studies, and some kind of computer scientists getting into this rather than architects getting into this, because architects feel that this is not their job. So this has to be inculcated into architectural students of architecture, that no, this is your job, and when you do it much better than when compared to others. The publications, when I see sometimes the terminology that is used is so basic, because they are not very close to architecture, and I mean, we should not find fault. And nowadays, all these research papers are written for the wider audience and multidisciplinary in their approach. But when architects do this kind of work, they tend to be very holistic in their approach and try to understand. And that understanding goes to architects, which can bring a lot about. See, I'm only talking about, see, the way Doshi understood, and he did IIM Bangalore, the environment, which probably not every individual can be so brilliant to sort of have that kind of pergolas and spaces and things like that. If you just walk around that place, you will be able to appreciate. But the same kind of a thing can be achieved scientifically, and today's machine learning, if you put it into place, and then which can be modeled and understood. That once the student understand the parameters, then he can do it on his own for any buildings. Then you won't need so much of technicalities. So the technical experiments are required for the students to tacitly understand the effect of all these parameters, which very scientifically they should be able to see. The very first question that I used to get when I was a student is, see, what happens if I put this window here? What size of a window should I have? Why should I have this size? I mean, what is the perfect answer for this? I mean, even today, I don't think we are able to come up with this very perfectly. Though we have norms, we have standards, we have various kinds of things, but it's a very subjective aspect. But we are not able to very objectively state this very clearly. So that kind of a research has to come in, and that should add into our the teaching learning material, that the content that see, unfortunately, the content is not very rich in these kinds of aspects relating to sustainability. So the content is always talking about, you either are flabbergasted by the achievements that they have done as an old or a very traditional, or go back to Indus Valley. They had 90 degrees roads. We are very fascinated to look at, but not getting into the science of the whole thing. So this is the problem, which is only appreciating as an art rather than getting into the science of it, which I think very lot of research is required into getting it, and developing good content for the students to read, and what are the parameters which are really affecting, how these parameters would go back to basic thermal comfort. If you're talking about what are the parameters, and then how these parameters affect, and what is the experiential aspect of it, how do we experience these things. So take them to a seashore and show them, yes, this is humidity, this is what it is. So you should know, low temperatures also, you're feeling very uncomfortable. Why? This is because of the humidity that is there in the seashore, maritime kind of weather. And that experience learning is a very important part of it, which fortunately probably very few like Charles Fourier Doshi kind of people were able to work with that kind of wide varieties of things. And Le Corbusier, when he built Sarabai House, it's not just trying to get into some fancies of it, but the basic science behind the whole thing was written as papers and published. It's such a fantastic thing to listen. And why they have become such masters is basically because of their involvement and understanding, which has intuitively probably came to them, which cannot come to every individual. That is the problem. So which has to be, see, we can't depend on intuition and chance. We have to depend on science, and we have to get more into scientific studies, and then definitively talking about certain things. What is definite? Talk about it. What is not definite? Okay, leave it. That can be subjective. But we should bank more on what we can definitively say in architectural education and drive those principles into the, because teachers will not be very, very frank. Teachers cannot take any side. They can't say, maybe, I believe. We have to go by these norms only. You can't say that you are wrong. You are right, because everything is not right or wrong. But here, we should bank on certain very, very clear principles. Added to this, then, okay, a lot of it can enrich. But that approach is very much essential, which is cannot come from one individual or one institution or one place. The entire set of architects have to get into, and there should be a lot of research which has to, useful research which has to come in, which can come out with lots of findings which are definitive. Very simple. I would say, I would challenge and tell anybody now, take up this research, come up with how do you fix up windows? What is the criteria? Starting all concepts, yes, you do all the things, and then come up with some very, very scientific approach. Publish a book, which will be very useful to architects in general. So do useful research than fancy research which gets into reports somewhere. So that climate related, sustainability related research, which is, and it has to be taught as a science. Science has to be taught as science, which has to be more experimental, experiential learning. Should be where science means which can happen, which you will be able to prove in any circumstance that scientific method. We cannot mythology type teaching we can't do for relating to climatology. So that subjectivity is there in architectural teachers. Anything we make it very, very subjective. Okay, what are the factors if that, what, and all those. Remove all those things. We definitely teach science as science, and then drive that into the students, and bank on, or try to create a bank of content which can definitely give confidence to the young minds, so that they can follow these principles and achieve something good. So this is an essential part of, otherwise we will be just superficially talking about sustainability. Sustainability will be always in the peripheries. We'll never be able to get to the core of the sustainability unless we get into these value systems. So which this part of the curriculum change, learning methodology, teaching learning methodologies have to be adopted, so that we can do a better sustainable, sustainability can be better integrated into the syllabus and curriculum.
Sure, sir. I think what you spoke about has been a very impactful point in terms of various things that you spoke about. One is the value system aspect, which you said has to be embedded, and I totally agree, because until and unless that particular mindset and value system is not there in a student, they will never really be able to apply it in the way you are suggesting it should be applied, in a very realistic way. Like you said, it should not just be for fancy purposes, but it should really, really, work for the purpose it is meant to. I think the second point, which came out very beautifully in today's response that you gave, was about the economization of such, aspects. A lot of times that now that we see sustainable restaurants or offices or various other spaces, we see there's a lot of cost which is involved in using such spaces, unfortunately, vis-a-vis the space that we usually use, which is made of the usual materials. So I think that was a very important point that you spoke about. Unfortunately, the sustainable material, which should have been cost effective, economized, has become the reverse. And of course, I think the main point that you were driving at today, which I think is a huge takeaway for institutions who are seeing this, is that the curriculum has to be really fluid, experimentative, and something that they can really work around with students and give them that freedom to think. I think the first time you said, there should be a lot of thinking on the part of students, you've been able to now give a very beautiful connection to that point through your response right now. Thank you so much, sir. Thank you. Shipra, I asked this question to sir from a completely institutional point of view. Again, I come back to you with a similar kind of question, slightly reframed, but from an industry point of view. What is the role of architecture in shaping the future of architecture? What are the key areas that you think are these are very complex issues that we are talking about, whether it is sustainability or climate change. How do you think can the industry train these students when they come into the industry to work for these specific areas to be focused on?
Just a moment. Can you come with the question again?
Yes, yes, I
Okay,
can.
So
Yes.
you're asking how the industry can be trained in these.
Yes, industry can students, because Sir talked a lot from
on the
perspective
sustainability.
of can work on them, what kind of changes they can bring about in their teaching
Yeah.
methods and their way of thinking while they're working with students. But from an industry point of view, it's again like a very complex topic.
Yeah. Sure. Thank you for that question. I'll answer that. So while Sir did say that sustainability is playing a very center role now, and with all these, you see so many initiatives which has been taken by government and even otherwise by private players also, like PMAY or Jal Jeevan Mission or Amrut or smart cities. But this gap still is there from the perspective of a fresh student versus industry's needs. So training definitely plays a major role. So training students and faculties to handle the complexities of climate responsive design requires, I think, a multifaceted approach that kind of integrates both theoretical knowledge and hands-on experience. So as climate change continues to be one of the most pressing issue in architecture, it is essential that students and professionals are equipped with the right skills, tools, and most importantly, mindset, which is needed to design buildings and urban spaces that minimize environmental impact, enhance resilience, and optimize energy performance. So what are these key strategies for preparing students and faculty to address the complexities of climate responsive design? First, I would say is incorporating climate science and environmental principles into the curricula for students. So I'll take it differently for students and then for faculty. So for students first, understanding climate zones and regional context. Students must learn how to design in different climatic conditions, ranging from hot arid climate to temperate, tropical, cold environments. This involves kind of understanding regional climate data, temperature, humidity, wind pattern, rainfall, etc., which is of course taught in schools in climatology, but that is just a subject. We don't incorporate these in our everyday projects, so which needs to be done. Second comes energy modeling and performance simulation, which Sir also talked about. So teach students to use software tools like Energy Plus. There is one design builder for energy modeling and simulations that predict how different climate responsive strategies, example, passive solar heating, shading, natural ventilation, affect a building's energy demand and comfort levels. Then comes thermal comfort principle. Students should be educated on the human aspects of climate responsive design, especially principles of thermal comfort, air quality, lighting, acoustics, which are essential for creating livable, sustainable spaces. Now, my point for faculty. Continual professional development. Faculty should regularly engage in workshops, training programs, and research that deepen their understanding of the latest climate responsive design strategies. Participating in climate change focused architecture conferences, collaborating with an environmental scientist, and staying up to date with advancements in sustainable building technologies will ensure they can teach relevant and current content. The second point for faculty is cross-disciplinary knowledge. Somebody who is teaching climatology knows only climatology. So that is not what will work now. So faculty should have access to and work with experts from environmental science, engineering, urban planning, urban designing to ensure a well-rounded interdisciplinary approach to climate responsive design is what I think. Second point is, again, which I said earlier also, hands-on learning through real-world projects. So to students, I'll say, design studios with real-world context. They should incorporate live climate responsive projects. For example, I'll tell you about, all of us have heard of all this massive flooding which happened in Chennai, and then drought condition, which is happening again across. So how does one deal with that? While we, institutions, studios and firms, we do such projects with the government, I think students should also take these up as real life cases, work with municipalities, urban local bodies, with different organizations, NGOs, as case studies in regions experiencing all these changes and challenges. So working on real projects that demand solutions to climate issues will help students understand the practicalities of implementing climate responsive strategies. Second is, again, sir already mentioned, I'm just reaffirming it, which is building prototypes and testing. Hands-on experience with material selection, model building and testing can be invaluable. So creating scale models, conducting tests on ventilation, shading, insulation performance can provide tangible understanding of how design decisions impact energy use and environmental performance. Then you do site-specific analysis, right? For faculty, again, collaborative research with industry. They cannot work in silos anymore. They need to be involved in interdisciplinary research that kind of directly addresses climate responsive design challenges. Again, collaboration is the key word here. Then living laboratories, living labs, establishing university living labs where faculty and students can experiment with climate responsive technologies such as passive solar system, green roof, advanced insulation material, etc., etc. Third point is interdisciplinary and collaborative learning. This I've already touched upon. Then emphasizing the use of advanced tools and technologies. You'll be surprised, there are so many technologies and tools which are available, which probably schools are not even aware of. So I would say, students, please read up as much as you can. Get to know about BIM and energy analysis software which are available in the market, which firms are already incorporating, and technology companies are already incorporating. These tools and technologies allow for integrated climate responsive design workflows, helping to optimize building performance and energy efficiency. There are tools like Dynamo, Rhino. So these are some very key softwares. Next is parametric and computational design. Get hands-on experience on those as well. Then climate resilient design technologies. Exposure to the latest climate resilient technologies includes green roofs, solar shading devices, rainwater harvesting systems, which is something very, very basic, and low impact materials. For faculty, again, continuous tool training. That's the key. Faculty must be familiar with the latest design and simulation tools, ensuring they can teach students how to integrate these technologies into their design process. Then collaboration with different technologists. That's also another key. Fifth point, which is most important, is fostering critical thinking on climate change and adaptation. Maybe you all can sit across the table, group of students and faculty as well, brainstorm. How do you tackle such problems, which probably we are also not able to handle? All these flooding, drought, whatever climate is throwing at you. You guys have the best brains. So develop an understanding of the broader issues related to these climate changes and design for resilience. So this focus on critical and holistic thinking is very, very important. So that is what is my take, Mikla, on how these students and faculty should be trained.
Thank you. Thank you so much, Shipra. I think in summary, the points that are coming out is really kind of coming in very well together for our students and faculty and institutions today, because what we are really trying to refer to here is a model in place where we are shifting from our age-old methods of teaching to something completely different, where there is a lot of freedom, a thought-based approach, where there is a lot of collaboration, like you said, and there is, of course, the need to think and do a lot of research on a particular topic before even jumping onto it. And like Sir said, experimenting with a lot of technologies, with a lot of methods, You suggested some beautiful tools today for students to work on. And I think these are a lot of takeaways for our student community and our faculty and institutions that we work with who are watching this webinar to take away from. We wanted to talk to both of you about so many more questions. We have questions from students, we have questions from various institutions which has poured in, but due to paucity of time, we'll stop here. However, we'd like to deeply thank both of you for your wonderful insights and inputs. I'm sure the students of today's time will be taking a lot with their hands full, from this webinar. Over to you, Neha, for a closing note.
This was a very fruitful and enriching discussion. And on behalf of the whole GHRDC team, I would like to express my appreciation and gratitude to everyone who has taken out time to attend the webinar. And our very sincere thanks to our panel of experts. Their presence has been invaluable and undoubtedly has made this webinar a very great success. Thank you so much, everyone, once again.
Thank you. Pleasure was all mine.
Thank you so much, Professor Srinivas. Thank you.
Thank you. Thank you.
Thank you.
Thanks a lot.
The recording of the webinar as well as some other details with you on email very shortly. Thank you so much.
Thank you. Thank you.
Bye-bye.